Hello everyone, let's continue with our preview of complex number, and today we're gonna discuss about the conjugate of complex number. So what is the conjugate? So conjugate of complex number mean the reflection or the mirror of your complex number from the horizontal axis. So let's take a look in the image on the right side. This is our complex number, and we're gonna find the reflection or the mirror of this complex number from the horizontal axis. So this is your horizontal axis, therefore you can tell that the mirror or the reflection gonna be this one. And let's have it the notation of z star. So if you rewrite it in a more mathematical term, if your reflection over the horizontal axis, a or your real part is still the same, but your imaginary part gonna be the reflection of b, which is negative b. Therefore, the conjugate of your complex number, or z star, is going to be equal to a minus bj. So this is going to be the form of a conjugate of a complex number. Very simple. You just replace the sign in front of your imaginary part with the minus sign or the negative sign. And in a polar form, you can rewrite it into r of e negative theta j. And why it makes sense to have negative theta? I mean, in here, the real complex number, you can have theta right here, and the reflection, which is on the bottom, gonna give you the negative theta. Therefore, the polar form gonna have the exponential of negative theta times j. So now let's discuss other useful properties of the conjugate complex number. So if you multiply your complex number with its conjugate, that's using the polar form for easier multiplication. So let's say r e theta j times the conjugate gonna be r e negative theta j. So those two exponential terms, you multiply them, you have positive theta and negative theta, and when you add it up, it's gonna be 0. Therefore, they are cancelled into 1. So you only have r squared. Therefore, the product of your complex number and its conjugate gonna give you the magnitude square. So how about adding the complex number with its own conjugate? What you're gonna get? So for addition, I prefer to use the Cartesian form because it's easier for us to add it up to complex number instead of like using the polar form. So for the complex number, it's gonna be a plus bj. And for the conjugate, it's gonna be a minus bj. So let's clean it up. You're gonna cancel this because this is positive and this is negative. They're gonna be 0. And a plus a is gonna be 2a. And since a is your real part, therefore you can say that it's gonna be 2 times the real part of your own complex number. So from this, you can say that your real part gonna be equal to your complex number plus its own conjugate divided by 2. So how about the subtraction? Let's say you're gonna subtract your complex number with its own conjugate. What you're gonna have? So a plus bj minus a minus bj. So let's simplify it. A plus bj minus a plus bj. So a cancel a, and then you're gonna have bj left. It's gonna be 2 times bj. And we know that b is your imaginary part, therefore you can rewrite it as 2 times imaginary of your complex number times j. Thus, imaginary part of your complex number gonna be your complex number subtract its conjugate divided by 2 times j. So in summary, you can get the real part by perform addition between the complex number and its own conjugate and divided by 2. And in order to get the imaginary part, you just gonna do the subtraction between your complex number with its own conjugate and divided by 2 times j. So after the example from the conjugate of a complex number, You have seen that we can perform addition, subtraction, and multiplication among two different complex numbers. So now let's expand it more in more formal way. So we have two complex numbers z1, z2, and I written it down in the Cartesian form as well as the polar form. So let's try addition between z1 and z2. So z1 plus z2, and you know, when you perform addition, you don't want to use the polar form, right? Because you're gonna stuck with an exponential term. Very difficult. But if you use Cartesian form, it's simple. It's just basic algebra. Therefore, your result gonna be a1 plus a2 plus b1 plus b2 times j. So this is gonna be your new complex number after the addition operation. So how about subtraction? z1 minus z2, and yeah, again, we're gonna use the Cartesian form rather than the polar because it's make our life easier. a1 minus a2, and then we're gonna have b1 minus b2 times j. So how about the multiplication between two complex numbers? So z1 times z2. So you can either use Cartesian form or polar form, either way is still working. So you can either have a1 plus b1j times a2 plus b2j, and if you use the polar form to perform the multiplication, you can have r1 times r2, and if you multiply to exponential together, then you're gonna perform the addition in the power term. So gonna be theta 1j plus theta 2j. So we're gonna have e, and theta 1j plus theta 2j, you're gonna have theta 1 plus theta 2, all of them gonna times j. So therefore you're gonna have theta 1 plus theta 2 times j. So how about the division between two complex numbers? So we're gonna have z1 divided by z2, and again, you can either use Cartesian form or polar form, but I would recommend using polar form because when you divide two exponential terms together, it's easier. We just subtract the power term together. So in Cartesian form, you're gonna have a1 plus b1j divided by a2 plus b2j, and if you use Cartesian, you have to simplify it so you can get a simplified complex number form, just like a plus bj. But if you use polar, you don't need to do that. So let's say r1 divided by r2, and then e theta 1j divided by e theta 2j, and if you simplify it, you can have r1 over r2, and e gonna be theta 1 minus theta 2 times j. So depend on how hard or how complicated your complex number, you're gonna use Cartesian or polar in order to perform arithmetic operation.